So now what we're going to do today is we're going to combine all of the rules that we learned before with our fractional rules as well. So let's go over this. So in order to do this, simplify basically means we're going to express what we have as a single power term. Once we've done that, we evaluate, means we're applying the exponent to the base. So every time we do these problems, we're always going to have to find a common base, bring all our powers together, simplify, either moving it from the top of a fraction to the bottom of a fraction, or just evaluating right away. All right, let's begin. So if we take a look at this problem here, we have two base powers of 5. Now what we're going to be doing is we're going to be trying to find a way to add these two fractions. Now the general rule is we basically take the two fractions and we just add them. Now remember, when we're adding fractions, the denominator stays the same, but the numerators here are added together. So now we end up having 10 over 5. So let's show that on our next line. So we have 5 to the 10 over 5. And now this is what we're going to do. Once we have 5 to the 10 over 5, we simplify that to 2. So this is our simplified form. We try to find our simplified form as the lowest, I guess, the simplified fraction, as much as we can use. Next, once we've got our basic fraction, our basic exponent, now we just apply it. So we have 5 to 25, it gives us 25. So this is going to be our evaluated form. Now, let's go through the rest of these problems and see if we can come up with similar solutions. So remember, every time we do this, we use power of a power, multiply and division first, deal with our negative and rational expressions, and then we try not to leave any fractions. We try to leave stuff in decimal form. We can leave stuff in fractional form in the end though. So here we go. So our first problem is 8 to the 3 over 4 divided by 8 to the negative 9 over 4. Using multiplication rules, we know that this is equal to 8 to the, well, this division means subtract. So we've got 3 over 4 minus 9 over 4, which is 3 over 4 minus negative 9 over 4, which gives us 12 over 4. So ends up having 8 to the 12 over 4 as our addition of exponents. So now we're going to simplify 12 over 4 to be 3, because 12 divided by 4 is 3. And then all we're going to do now is we're going to apply our exponent and get our evaluated form, which is 512. Our next problem has power of a power. Now you need to remember that when we do power of a power, it means we're multiplying two parts. So let's just do that right away. Let's just do that off to the side here. 1 over 4 times 8 over 3. So if you realize when we're multiplying fractions, we just multiply the tops and we multiply the bottoms. So now we have 8 divided by 12. So let's go and write our fractional form. 8 to the 8 over 12. Now, just as a side note, none of you can calculate the 12th root of 8 in your head. Okay? Every time we do these problems, there's going to be times when you're actually just working on simplifying the fraction so that we can get a radical that will be easy to calculate. So now that we have 8 over 12, we're going to reduce that fraction by dividing the top and bottom of 8 and 12 by a common denominator, which would be 4. Something that could divide both of them. So it would be the lowest common multiple. Yeah, okay. Greatest common divisor is 4 in this regard. So we're going to divide both the top and the bottom by 4 of this fraction. So now we've got, well, 8 to the 2 over 3. And based on our rules for fractional exponents, this is the same as having 3, the third root of 8 raised to the power of 2. And the third root of 8 is just 2. And we're still raising that to the power of 2, so the power of 2 is 4. Now, as a quick note, back to the aside, we could punch that in our calculator and we would get 4, but we need to be able to do this in our heads. Now, let's work on the final problem. The final problem is going to be quite a doozy. That's why I've made some extra space here. This should be a 4-line problem. So let's do this. Now, when we write this problem, we need to be able to multiply using power of a power on these two fractions. So just like we did back here, where we multiplied the exponent and then put our result on as our exponent on our base, we're going to do the same for this one. Now, let's focus on that again. Multiplying that out. So I'm actually going to go a little faster this time. Well, the numerators are 4 and 1, right? So what we're going to do is we're going to multiply those two together right away. So we're going to get, our base is still 27. The numerators multiplied against each other are 1 and -4. So we get -4 on the top of our fraction in the exponent. And on the bottom we have 2 times 3, which will give us 6. So now we have to reduce our fraction. So we can write this as 27 to the -2, or is it -3? I think it's -2. So we can divide both the top and bottom of the fraction by 2 to get 27 to the -2 over 3. And then we're going to, well, imagine that this is all over 1. Put our brackets in, and then what we're going to do is we're going to immediately flip our fraction and follow the rules that we have for our square rooting. So now we have 1 over, well, the third root of 27 all raised to the 2. So now we have 1 over, well, the third root of 27 is 3. And then we get 1 over 9 as our final answer. Your homework for this lesson is on the website in lesson 6. It's combining rules. It's using exactly the same setup for all of these problems. Good luck.